Hey everyone, and welcome to this explainer. Today we're taking a plain English, no-nonsense look at a fascinating article detailing what is arguably the biggest, most exciting shift happening in the world of artificial intelligence right now. For the past few years, we've all been totally mesmerized by AI that generates text by, well, essentially guessing the next word in a sequence. But the industry is hitting a wall. To get genuinely smarter, AI needs to stop just guessing and start connecting the dots. That massive shift is called graph engineering, and it's completely rewiring how AI systems process information. Now, what's really interesting about this quote is how fast it caught on. Back on July 18, 2026, a developer named Peter Steinberger posted this exact 12-word question on social media, and it absolutely set the AI community on fire. Literally within 48 hours, everyone was debating what graph engineering actually meant and why standard AI agent loops were suddenly feeling, well, a bit outdated. It was the spark that dragged a highly technical, behind-the-scenes engineering shift right into the mainstream spotlight. So, that brings us to the big, essential question for today. What exactly is graph engineering, and why on earth is it changing AI so fundamentally? In this explainer, we're going to strip away all that overwhelming technical jargon. We're going to take a journey from the old way of feeding AI flat, isolated data, straight into a brand new paradigm of interconnected knowledge. Section 1. The AI knowledge problem. Okay, so here's the core issue. Standard AI approaches treat your data like a giant, messy pile of flat documents. When you ask it a question, it searches through all that text like it's hunting for a needle in a haystack. The problem? Well, standard language models struggle heavily with what engineers call positional context. Basically, if they have to read through a massive document to find an answer, by the time they reach the end, they kind of forget what they read at the beginning. Because they can't see the big picture, they miss vital connections. And worse, they start hallucinating. Making up facts that sound super plausible but are just completely wrong. Okay, let's dive into this. Section 2. What is a graph? Simply put, a knowledge graph is a map. Instead of just tossing an AI agent a huge stack of flat documents and crossing your fingers that it finds the right connections on the fly, you're building a literal, explicit map of how things connect beforehand. You take all your data and organize it into nodes, which are the actual things, and typed edges, which represent the specific relationships between those things. Once you've built this map, the AI can actually traverse it. It walks from point A to point B along a guaranteed, verified path of truth. If we contrast these two approaches side by side, honestly, the difference is night and day. Standard search relies on vector similarity. Think of it like a really advanced keyword search that grabs chunks of text and uses them to guess the next logical word. Graph traversal, on the other hand, relies on connected relationships. It allows the AI to perform complex, multi-hop reasoning. It doesn't just know that two documents are related, it actually knows exactly how and why the concepts inside them are related. Section 3. Nodes, edges, and connections. And this brilliantly illustrates a really important point. Building these maps isn't just cold, robotic math. It absolutely requires human intelligence. Researchers agree that people, specifically domain experts within a company, still have to sit down and agree on how their world actually works. Like, what officially defines a customer? Or how does a specific product relate to the supply chain? The AI can only traverse the map if humans have correctly defined the rules of the territory first. If you want to strip away all the corporate buzzwords entirely, just think back to grade school grammar. Nodes are your nouns. A node is a customer, a product, a software module, maybe a patient. The edges? Those are your verbs. An edge is the action connecting them, like purchased, depends on, or caused. Look, any standard search engine can find two related nouns, but the typed edge, the verb, is the actual knowledge. It's the secret sauce that allows an AI agent to confidently answer why things are connected. Moving on to Section 4, the 5 steps to graphs. So here's a journey from raw information to genuinely smart AI. First, you capture the data. That means gathering all the raw first-party information your company uniquely owns. Second, you map it. Human experts step in to create the rules and categories for how things relate. Third, you populate the graph. You extract all those nouns and verbs from your data to physically build out the map. Fourth, you enhance the AI, allowing systems to use graph retrieval augmented generation, or GraphRAG, to explore this new map. And finally, application use, delivering this incredibly accurate AI to your end users safely and securely. Section 5, real-world graph power. So the crucial point is this massive number right here, 85%. By feeding AI a structured graph instead of flat text, researchers have seen a reduction in AI hallucinations by nearly 85% on average. That is huge. When you give the AI a map of explicit facts instead of forcing it to guess, it literally stops making things up. For industries like healthcare, manufacturing, or law, where a wrong answer can be absolutely catastrophic, that 85% reduction is a total game changer. But hey, it's not just more accurate, it is incredibly fast. Real-world implementations show that GraphRAG cuts query times by 70 to 80%. Think about it. If an AI has to read 1,000 pages of text to find an answer, that takes massive computational time. But if it can just instantly hop along a predefined path of connected nodes, it retrieves the answer in milliseconds. The dots are already connected, so the AI doesn't have to do all that heavy lifting at runtime. Let's move to and see how this builds when the questions get complicated. We're talking about multi-hop reasoning. This is when a question requires pulling information from across many different documents. For example, why was the software module changed and what downstream systems were affected? In benchmark testing, Graph Systems scored 53.4% accuracy on these complex questions, completely blowing standard vector-only retrieval out of the water, which scored just 42.9%. The takeaway? When the question requires a journey, you absolutely need a map. To prove this isn't just academic theory, look at the financial sector. Fintech companies are aggressively racing toward graph engineering to solve massive real-world problems like fraud detection and anti-money laundering. Traditional databases really struggle to see complex rings of fraudulent transactions because all the data is stored in isolated tables. But a graph database? It instantly reveals the hidden connections, showing exactly how money is bouncing from one account to another in a suspicious pattern. Section 6. Connecting the final dots. Before we wrap up, I want to bring our focus back to the human element for a second. Because as much as graph engineering relies on automated pipelines and super advanced algorithms, it ultimately all comes back to human accountability. We need stewards to govern these enterprise systems, to ensure the data is high quality, and to verify that the map we are building actually reflects reality. At the end of the day, we are the ones teaching the AI how our world connects. To wrap up our core analogy, standard AI forces models to blindly search for a needle in a haystack. Graph engineering gives the AI a literal map of how every single piece of hay is connected. By taking the time to structure your first-party data, your company's unique internal knowledge, you upgrade your AI from a fast-talking guesser into a genuinely smart, highly reliable reasoning engine. The shift from flat data to interconnected knowledge is already unlocking massive improvements in speed, accuracy, and reasoning. But honestly, this is just the beginning of the journey. The map is being built right now as we speak. So the question we leave you with today is this. When AI finally has all the dots connected, what hidden insights will it discover next? Thanks for joining me for this explainer and keep exploring.
If you found this useful, don't forget to hit the like button. It really helps the channel. Subscribe so you don't miss future videos, and share this video with someone who needs to see this. It helps grow the audience and lets us create more content like this for you.